In this lesson, we're going to talk about solving quadratics using factoring. When you're solving an equation, you're trying to figure out what value of x makes the equation true. If you look at something like number 1, you have 3x plus 15. Because we don't have an equal sign, we can't solve that. Just like the problems we've been doing with factoring had no equal sign, so they were just expressions. Expressions cannot be solved, but equations can. For example, on example 2, you're trying to solve for x, so you would subtract 3 and then divide by 2, and that would give you your answer. You're solving for what value of x works for that equation. We've done some solving of quadratics already using square roots, so this is a little bit of a review. We used square roots when the equations were in vertex form. So they were in that form of a times x minus h squared plus k. Anytime they looked like that, we wanted to use the square root method. So on number 1, since the squared term is isolated already, x squared, we would take the square root of both sides. Remember, when you do that, you need a plus or minus on your number. So the square root of x squared is x. The square root of 9 is 3, so plus or minus 3. On the second one, x squared is not isolated, so we would add 4 to both sides. So x squared equals 24. And then we would take the square root of both sides. Remember to put your plus or minus in there. So x is equal to plus or minus the square root of 24. And then on those problems, we took it a step further and simplified the square root of 24. That's the square root of 4 times the square root of 6. So 2 times the square root of 6. So x was equal to plus or minus 2 times the square root of 6. You'll notice on each of these, we're finding the value of x that works in the equation. On this last one, we're still in vertex form, so we're going to divide by 2 to isolate the square term. And we get x minus 3 squared equals 9. We would take the square root of both sides once the square term was isolated. Don't forget that plus or minus. And we would get x minus 3 is equal to plus or minus the square root of 9 is 3. Add 3 to both sides. And x is equal to 6 or 0. So that's solving quadratics using square roots. And that method is great if you're in vertex form. What we're going to move on to is, what if it's not in vertex form? These are going to look more like standard form, where you have ax squared plus bx plus c. The first thing you need to do is get it equal to 0. So if your equation, like on our first example here, is not equal to 0, that's our first thing. So we're going to move the 4 over by subtracting. So x squared plus 3x minus 4 equals 0. And then we're going to factor. We need the factors of negative 4 that add to give us positive 3. So that's x plus 4 and x minus 1. The next part is the part that's really new. We need to figure out what values of x make this true. We know that x plus 4 times x minus 1 has to equal 0. Well, if I know that 3 times some variable, say it was a, equals 0, what do I know about a? Well, a must be 0, because you have to multiply by 0 to get 0. What that means for us is that either x plus 4 or x minus 1 or both have to equal 0 to make this work. This is where we have to look at what value of x can I plug in that makes x plus 4 equal to 0. Well, if x was negative 4, that would work. And then what value of x can I plug in here that would make that 0? That would be positive 1. So x is equal to negative 4 and positive 1. If I plug those in and check, I'm going to take this right over here to do my check. I'm going to plug in a negative 4 for x first. So negative 4 squared plus 3 times negative 4. And I'm going to see if that gives me positive 4. Negative 4 squared is 16. Plus 3 times negative 4 is 12. Does that equal 4? And it does, so we know that our first answer was correct. And then I'm going to plug in the 1. So 1 squared is 1 plus 3 times 1 is 3. Does that equal 4? And we know that it does. So both of our answers work to make that statement true. Erase this. So your first step is to get it equal to 0. Then we factor, and then we figure out what value of x makes each one of those binomials equal to 0. All right, so the next one, we have negative x squared plus 8x equals 15. When we look at this one, we know we need to get it equal to 0, and you may notice that your a is negative. Here we've got a negative x squared. And so if a is negative, we're going to move the a and everything that's with it to the other side. So instead of bringing the 15 over here, we're going to add x squared to both sides, and we're going to subtract the 8x from both sides. So we get 0 on our left-hand side, and then we're going to put this other in standard form, so we're going to list our exponents high to low. That means the x squared comes first, then the x, and then the constant term at the end. So we have it equal to 0. We know that's the first step. Then we factor. To get x squared, we do x times x. Then we need factors of 15, 1 and 15, or 3 and 5 that add to give you negative 8. It's going to need to be negative 3 and negative 5. Once it's factored, we're ready to find x and to say what value of x can I plug in here to make that 0. Positive 3, because 3 minus 3 would be 0. And then what value can I plug in here? Positive 5, because 5 minus 5 is 0. So x is equal to 3 and positive 5. I'm still going to plug those back in to check them. If I check the 3 first, 3 squared is 9, so that's going to be negative 9 plus 24. Does that equal 15? And it does. And then we'll plug in the 5. So 5 squared is 25. Negative 25 plus 8 times 5 is 40. Does that give me 15? Yes. And so I know my answers are correct because I can plug them back in and check them. All right, our last one here is x squared minus 8x plus 16 equals 0. It's already equal to 0, so it's ready for us to factor. X times x is x squared. We need factors of 16, positive 16, that add to give us negative 8. So we know they're both going to be negative. Is it 1 and 16, 2 and 8, or 4 and 4? It's going to be 4 and 4. What value of x makes that 0? Positive 4. And then what value of x makes this second one? It's also a positive 4. We only need to list it once if it's the same number. Then we're going to plug it back in and check it. 4 squared is 16, minus 8 times 4 is minus 32, and then plus 16. Does that equal 0? And it does, so that's our answer. So for each one of these, you're getting it equal to 0, you're factoring it, and then you're finding out the value of the value of x that makes each piece equal 0. If you want, you can set each one of those equal to 0 in their own equations. You could come over here and say x minus 4 has to equal 0. So if I solve that, I would add 4 to both sides and I get x equals 4. It's the same for that one, so we wouldn't work that twice. But this is possible. This is something I usually do if I can't look at it and tell. Like when I look at x minus 4, I know if I plug in a 4 for x that I get 0. I don't have to give a lot of thought to that. But some of them are going to be a little more complicated. So if you want to use this method of setting it equal to 0, you can do that. Don't forget to look for common factors when you're factoring. Both of these are already set equal to 0, so we don't have to worry about that step. On the first one, what factor do you notice that 2x squared and 4x have in common? They have a 2 and an x. So we're going to factor out the 2x. We're left with x minus 2 equals 0. Then I want I'm finished factoring, so I want to know what value of x makes it 0. 2 times what gives me 0? 0. And then what minus 2 gives me 0? 2. So x is equal to 0 and 2. On the next one, we have 5x squared plus 20x equals 0. I can factor out a common factor of 5x. I'm left with x plus 4. So once it's factored, we're ready to find x. 5 times what gives me 0? 0. And what value of x makes x plus 4 0? Negative 4. Sometimes you'll come across problems that are already factored for you. If it's a binomial times a binomial already equal to 0, it's ready for you to solve. All you have to write is x equals what value of x makes x minus 2 0? That's 2. What value of x makes this one 0? Negative 3. That's it. On the next ones, these are the ones I was talking about that it's a little harder to tell what value of x makes that 0. 2 times what plus 1 equals 0. Well, if it's not as easy to tell, then that's when you want to set the linear part equal to 0. 2x plus 1 equal to 0, and 3x plus 2 equal to 0. And we just solve those like basic linear equations. Subtract 1 from both sides, and we get 2x equals negative 1. Divide by 2, and x is equal to negative 1/2. Over here on the right equation, we're going to subtract 2 from both sides. So 3x equals negative 2. Divide by 3, and x equals negative 2/3. So we just set each piece equal to 0. On this last one, I'm going to do the same thing. I'm going to set each one of those equal to 0 because it's already factored. So 2x minus 5 needs to equal 0, and 4x minus 1 needs to equal 0. Add 5 to both sides, and we get 2x equals 5. Divide by 2, and x equals 5/2. And then for the one on the right, you just add 1 to both sides, so 4x equals 1. Divide by 4, and x equals 1/4. When that number in front of x is anything other than a 1, you're going to end up with a fraction on these. So you can look at those and say, okay, I know these are the ones that deal with the fractions. So that's how we use factoring to solve. That's where that part stops. What I want to show you is how this relates back to the graphs that we were talking about at the beginning of the unit. We graphed the parabolas and we talked about different types of them. So in the next video, I'm going to show you that.